remember section 10's quiz, but it's basically yours. The numbers might have been moved around, so but all the problems are basically the same, along with the answers. So as long as you understand this, you can see what the answers are for your version of the test. Okay, so I was basically checking you if you understand what a function is. Remember, function has each input only has one output. So I kind of look for anything that breaks the rule, right? So 2 goes to 6 and 2 goes to 5. That means the input of 2 had 2 outputs, and 6 has 2 outputs as well. Can't be that. 0 goes to 1, 0 goes to 2. Can't be that. 4 goes to 6, 4 goes to 8. Can't be that. Leaves us with our only possible answer, which is A. Number 2, we're trying to do the same thing, but the table is a little different. It's in X and Y, but we look for the same stuff. Well, in table A, -1 outputs 3, but then it also outputs 6. Not a function. B, well, none of the x's repeats. That's a good chance it might be it. Let's check here. 0, 2, 0, 6. Nope. -2, 4, -2, -4. Nope. Yep, so we were right. It's there. Okay, which of these is not a function? Well, it's something called the vertical line test. It tests to see if an input, an x value, has more than one output. Okay, so what you do is you pick any x you look at the graph and you decide, like if I go up from when x is 1, does it only touch it once? Yes. Function. What about 2? What about 3? What about 4? Yes, so it's basically a vertical line can tell you whether it's not a function. In this case, it's a function. The one that it leaves us 2, the only one that's not a function of all 3 of these is A. You can pick any x value, and you will see, at least that the graph shows, except maybe right here, but yeah, it touches twice. So when x is 2, there's 1, 2 y values that go with it. So this one is not the function. And you can just pause me or rewind me if you want to hear me talk about it again. Okay, so which graph represents the ordered pairs of the function y equals 2x? Well, we've been graphing. So the thing you want to do is make a table, we know y equals 2x, and pick some points, right? Well, you could see from all of these, it starts at 0, 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. I'll plug it into my function, 2 times 1, and 2 times 2, 2 times 3, 2 times 4, because it says 2 times x. I get 2, 4, 6, 8. So which of these graphs has the point all of these? Well, let's take 1, 2, for example. Point 1, 2. This one has it. Let's check over here. Does this have it? 1, 2. Nope. This point? Nope. This point? Nope. We'll just follow up. It must be this one because 2, 4 is here, 3, 6 is here, and 4, 8 is it. So it must have been this one. In number 5. Now here's a list of ordered pairs. Which one is a function? Well, we try to find one where each input only has one output. If we take a look at, I don't know, let's start at D. 1 gives us 2, 1 gives us 4, that can't be true. And then here again, this shows that it's not a function. -1 goes to 2 and -1 goes to 3, that's not a function. 2 goes to 6 and 2 goes to 7, that's not a function. So it must be A, and yes, each input only has one output. Number 6, I thought was super easy. Function notation is f of x or g of x. So if I want to write y equals 3x minus 10 in function notation, I just switch out y with f of x. No work to be done. Y is the same as function of x. You could have said g of x equals 3x minus 10. Whatever you want. Remember, the letter in front, or whatever you write in the front, is the name of the function. This is function f, g, or h. Any of those would have worked. Number 7, domain and range of this function. Well, the domain and range are basically right there. Domain is our x values. So -1, -2, -1, 0, and 1. And your range is 4, 1, 0, 4. But we already said 4 here, so you should not include it. When you don't have to repeat values of the domain or range, okay? And some of you would have lost points for that one. So since 4 was said here, I don't need to write it at the end. I'm only listing the numbers that appear in the domain and range. And hopefully after the do now, it makes more sense. Okay, number 8. You gotta, here's the domain, here's the range. It might be nice if you made a little table in your notebook to help you find the y values, which f of x is y. So again, you just plug in your value for x, wherever x is, and then you just do the math. Negative 1 squared is 1 plus 1 is 2. 0 squared is 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. I did want you to list them as ordered pairs, but I didn't take points off if you didn't. But negative 1, 2, 0, 1, 1, 2, 2, 5, and 3, 10. Okay, number 9. What's the domain of this function? Well, again, domain is x values. And since this graph is going up to the right, so it's going to the right, it's going to keep having x values to the right. But it also goes up and to the left. We're more concerned about going to the left. So that means every x value is going to be used to make this graph because it goes on forever. That means our domain is all real numbers. There's no beginning and there's no end for the going right or left. So that tells you it's all real numbers. The range is a little different because the range doesn't go down forever and up forever. Some of you noticed, and wasn't part of the quiz, but they noticed that the low point for the y's are at -3 and everything above works because it goes up forever from there. So the range is y is greater than or equal to -3. All right. I'm just going to focus on what it says, right? It says, what is the domain or range of this graph? Well, the domain is our x's, right? And we have a beginning point and an end point for the x. So our beginning x value is 3. Our ending value is 6. And every single point between it isn't. So we know we're going to have to use a compound inequality to say everything between 3 and 6. Our range also has beginning and end point. Begins here at 2 and it ends up here at 7, and everything in between is used too. So we're going to use this compound inequality statement. Okay, I have to add a second part because I can see how far we can get. Okay, the larger the size of the dog, the more pounds it would eat. So the amount of food eaten depends on the size of the dog. My dog, which is small, will definitely eat less food than a big giant dog, right? So our dependent variable, because the food depends, is the food eaten. The food depends. And the independent is the size of the dog. Okay. That was slightly tricky. People try to fit it the other way, but it just doesn't work. All right, the last one, find f of 2. So that's function notation. So that just says take 2 and put it into where x is. And find the answer. So 2 squared is 4. 4 times, following orders of operations, 4 times 2 is 8 minus 12. 4 plus 8 is 12. So you get 0. So f of 2 equals 0. So if you input 2, you get out 0. Okay? I also went over this in class, but this is just a chance if anyone wants to watch it one more time. And you might have to find where these are listed, but you basically have the same problems.